Hornets, welcome and thank you for joining me today. We're going to be talking about finding multiple solutions in terms of trigonometry. Now, the types of problems that we're going to be dealing with are problems that involve our basic sine, cosine functions, but that have higher coefficients than 1 in front of theta. So let's go ahead and start with something very simple. This is what we talked about a little bit today. And the whole idea that when we have something like the sine of 2 theta equaling root 2 over 2. Now, we know that our domain that we're looking for the solutions on can be anything, for example, between 0, pi, and let's go to something like 5 pi. Okay? Now, in order for us to find our solutions, we are going to start by using what is referred to as a dummy variable. And we always want to define what that dummy variable is. Secondly, the dummy variable needs to be more simplistic than what we're trying to solve, or there's no reason using it. Okay? So here is the first type of dummy variable that we often use. And I'd like to use alpha for my angles and u for my expressions. So for example, if I wanted to replace sine or cosine of theta, I would replace them with a u. But in this case, when I have 2 theta, which is an angle, I'm going to use an alpha. Now, any substitution can work, all right? You just have to define it. So I'm going to now do the problem as if alpha were the angle as opposed to 2 theta. And I'm now going to find my two solutions between 0 and 2 pi that are going to solve this. And if I'm working with my radians from 0 to 2 pi, I can work with pi over 4. That's in the first quadrant. And then I have 3 pi over 4. And 3 pi over 4 is also between 0 and 2 pi. Now, because I've gone all the way to 5 pi, I'm going to keep going, and I'm going to look at it in terms of 9 pi over 4. And you'll notice 9 pi over 4, I believe, is going to be less than 5 pi, being approximately 2.5. So I'm now looking at these values over this domain, and I'm now going to say that pi over 4 plus 2 pi k is equal to alpha. Then I'm going to have alpha equal to 3 pi over 4 plus 2 pi k. And please be aware that the pi over 4 plus 2 pi k will also give me 9 pi over 4 as a coterminal. So I'm going to work with these two. I'm now going to replace my alpha with what we called alpha to be. So this is going to become 2 theta equals pi over 4 plus 2 pi k. This will allow me to multiply everything by 1 over 2, so that theta is now pi over 8 plus pi k. I'm now going to let k equal 1 and 0 and 2. And we're going to try and find every single theta that is less than 5 pi going through this process. So I'm going to let k equal 0. When k is 0, I have pi over 8. When k equals 1, I have 9 pi over 8. See how I just added 8/8 to that 1/8. Then I'm going to do it again. I'm going to let k equal 2. And I'm now looking at adding 16 plus 1 makes 17 pi over 8. Now I want to quickly check. Is 17 divided by 8 less than 5? We'll find out. 17 divided by 8. Well, that's 2.15. Okay, well, I can keep going then, can't I? So let's keep going and let's find k equals 3. That means I now have 25 pi over 8. And let's just check 25/8. That's 3.125. So I'm going to let k equal 4. And I'm now going to add another 8/8, which is now 33 pi eighths. 33 divided by 8, that's 4.125. K equaling 5 is now 41 pi over 8. But I know that 41 is going to be 5.125, or 5 1/8, and that is beyond 5 pi. So I stop right there. And these are my first solutions. I'm now going to look at 3 pi over 8 plus pi k, following the exact same thing. Notice, all I did was take 2 theta equals 3 pi over 4 plus 2 pi k, and I'm now going to add and find my solution by dividing by 2, and I get 3 pi over 8 divided by plus pi k. We're now going to let k equal 0. I get 3 pi over 8. I let k equal 1, and I'm adding 8 for 11 pi over 8. And I have k equaling 2. That's now 19 pi over 8. K equals 3. That's 27 pi over 8. K equals 4. And I'm looking at 35 pi over 8. Those are separated by 2. And I'm going to then let k equal 5 and check that one as well. And I get 43 pi over 8. Too much, cancel it. Now, I'm now going to go to that 9 pi over 4. Now, you'll notice when I do 9 pi over 4 equaling the 2 theta plus 2 pi k, I divide by 2, I get theta equals 9 pi over 8 plus pi k. And you'll notice, there it is right there. That's 9 pi over 8. If I then add pi to it, I get 17 pi over 8, 25 pi over 8, 33 pi over 8. They are all coterminals, and I stop at the last one, which means that it does me no good to use that coterminal, because that coterminal right there is being given all of my answers right here. So there's no use for us having to do that. Now, once we've gotten all of this work, we're going to put our answers together. Pi over 8, 3 pi over 8, and we're just listing them as a solution. 9 pi over 8, 11 pi over 8, 17 pi over 8, let's see, 19 pi over 8, 25 pi over 8, 27 pi over 8. Again, I'm just listing them all down. We have 33 pi over 8, and we have 35 pi over 8. These are now the solutions between 0 and 5 pi for the function sine 2 theta equals root 2 over 2. You notice it's not that difficult. We just have to make sure we follow all of our steps. Let's take another one. This time, go ahead and look at, say, the cosine of 3 theta is equal to 1/2. Alrighty, we're going to let alpha equal 3 theta. We're then going to look at the cosine of alpha equals 1/2. Our reference angle is pi over 3. So we have pi over 3 in the first quadrant, but cosine is going to be positive in the fourth quadrant, and that's 5 pi over 3. So we're now going to set it up as 3, or our alpha, let's just take it one step at a time, Mr. Lamb, pi over 3 plus 2 pi k, and alpha equals 5 pi over 3 plus 2 pi k. We're now going to replace alpha with our 3 theta, so that 3 theta equals pi over 3 plus 2 pi over k. 3 theta is equal to 5 pi over 3 plus 2 pi k. Dividing by 3, theta is going to end up being pi over 9 plus 2 pi over 3 times k, and theta equals 5 pi over 9 plus 2 pi over 3k. And I can now go to plugging in k equals 1, 2, 3. Now, what are we working with? Well, normally we would work with our radians between 0 pi to 2 pi. And once again, it could be any pi. I could have 4 pi, 5 pi, 7 pi, 3 pi. I could have even non-standard things like 17 pi over 12 or something bizarre. All right? So just be aware, whatever solutions we find have to be within this domain. Okay? That's our limit. That's our constriction. That's what we have to make sure we are successful in. So let's go ahead and plug in k equaling 1 or 0. My first answer is pi over 9, and my second answer is 5 pi over 9. I'm going to have to make sure that I get a common denominator, and you'll notice that that would be 6/9. So I'm going to add 6/9 every time my k goes up. So if I have k equals 1, I'm looking at 7 pi over 9 and 11 pi over 9. Notice they separate by 4, separated by 4. K equaling 2, I'm now going to add another 6 pi over 9, and I get 13 pi over 9. I get 17 pi over 9. Let's do one more, k equals 3. That's going to give me 19 pi over 9, and I'm going to have 23 pi over 9. Now stop and think about it. It's got to be less than 2 pi. 2 pi would be 18 pi over 9, which means that 19 is too much and 23 is too much. I can now write my solutions down in my solution set. Pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Once again, not very difficult. Now, when we're solving things of this nature, they can be anything. So far, I've just been doing sine and cosine. But what happens if I want a tangent? Let's take a look at a tangent, okay? Let's say that we have the tangent of 2 theta. Let's keep it simple. And we're going to say that the tangent of 2 theta is going to be root 3. That means that our alpha is 2 theta, and we're now looking at the tangent of alpha equaling root 3. We're now going to write these two solutions down. This is going to be in the first and third quadrant, where tangent is positive. The reference angle for a root 3 is going to end up being pi over 3. So the second answer would have to be 4 pi over 3 in the third quadrant. We then have alpha equals pi over 3 plus pi k. Now notice, if I add pi to it, I get this. So I don't have to work with that one. That's just going to give me repeated answers. Just like we saw in the previous problem a moment ago, where I had a coterminal, 9 pi over 4, because it was within 5 pi. But here, every time I had that coterminal, it repeated it anyway. See, we've repeated them anyway. As a result, I'm not going to look at that second option. I'm only going to work with my first one. 2 theta equals pi over 3 plus pi k. And I'm now going to divide by 2. Pi over 6 plus pi over 2k. Notice that means that I'm going to be adding 3 pi over 6. So my first answer is pi over 6. The second answer is going to be 4 pi over 6. The next answer is 7 pi over 6. The next answer of that is 10 pi over 6. And we can keep doing this, right? Another one's going to be 13 pi over 6. And we have to ask ourselves, well, what is our range? What is we're working with? Well, the domain Again, I'm going to keep it simple. I'm going to call it between 0 and 2 pi. Anything over 2 pi, we have to throw away. Here we go. My first solution is pi over 6. The second solution is 2 pi over 3. Notice I have to reduce my solutions. Then 7 pi over 6. And my last one is 5 pi over 3. And there is my solution set for this equation. Once again, we start off in the same way. Coterminals we don't work with, we just ignore. And we find our one solution possibility with all of its rotations and coterminals. Then we equate in terms of our denominator so that we can add 3 pi over 6 over and over and over again. When we write them in our solution set, we make sure that we reduce them. Now, this can work with secant and cosecant, sine, cosine, tangent, cotangent. Now, the only two that work with pi k are tangent and cotangent, and all of the other ones are going to work with that 2 pi k. All righty. So that's finding solutions, multiple solutions, specifically when we have a coefficient in front of our theta. Once again, these are exact values. However, I could just as easily do this using our calculator with non-values in terms of radians. I could even do it in terms of degrees. So be aware, if I were doing periods in terms of degrees for tangent and cotangent, I'd be adding 180k. When I'm working with sine, cosine, secant, and cosecant, which is 2 pi k, I would work with 360k. All righty. I hope this is something that you found reasonable and that you found understandable. This is what we talked about in class today, and we will continue to work with this as we move forward and continue to practice. Thank you very much for being here and listening to this, and I hope it helps. Thank you. Be well, take care, and I hope you have a wonderful evening. Cheers.